All of you. I hope you all are doing well. So today we are going to learn the 8086 logical programming. In the previous lecture, we have studied arithmetic programming, so addition, subtraction, okay, multiplication, division. All these programming we have seen in the previous lecture. If anyone has not gone through this lecture, kindly see this lecture and then come to this lecture. So So today we will start with the logical programming. So now tell me, so in your mind, what will be the question if I will say the logical programming? Yes, absolutely right. We are going to do the logical programming means the and or XOR not all these operations how they can be performed using the 8086 programming. Sometimes what happen, we have to do the AND operation between two numbers, okay, two hexadecimal numbers, or there are two decimal numbers. So all the 8086 programming we are doing in a hexadecimal number mostly. So while doing this ANDing or NOR or XOR operation, we have to write some program, okay. So all the time we cannot do by the all these things by using the manually, so we need some instructions, and how that instruction can be performed, that we are going to learn in this lecture. So let's start. So first, what kind of logical programming or instructions which is having and or not and XOR, all these four programming or also the logical expressions that we are going to perform using the 8086 programming. So the logical instructions and or not XOR test. These bytes of instructions are used for carrying out by the bit by bit shift, rotate or basic logical operations. Now here we are going to use this ANDing or AND or not or XOR operation while doing the shift the or rotate or for some basic logical operations. All the conditional code flags are affected depending upon the result. Now there are carry flag, then zero flag, auxiliary flag. All these flags are affected according to the results. So what kind of result which are having or where we are going to use this flag, or this flag can be affected by using some results. So basic logical operations available with 8086 instruction set and or not and XOR. Okay, so these are basic logical operations. So these are nothing but the basic operations or logical operations which are performed using the these some instructions of and or not and XOR. So first we'll start with the and. So and, that is a logical and, this instruction bit by bit. So what is the meaning of this? So we are performing this instructions bit by bit, means we are doing the operation on individual bit. What is meaning of this? Suppose I am writing 12, right? So what is the, or we can say binary b, sorry, hexadecimal b. So b means 12. So how we will write in a decimal, in a binary? So 12 is nothing but 1 means 8, 0, 8 and 4 means 1, 1 0 0. So in binary it will be write as a 1 1 0 0, and I'm ending with the 10. Okay, so I'm ending with the 10, means what is the 10 binary? So 10 binary is 1 0 1 0. Okay, so what I'm going to do here, suppose 12, that will be written as 1 1 0 0, and 10 is 1 0 1 0. Okay, and I have to perform the AND operation. Then how I will perform? So what is the, now truth table of AND is what now? So we all know the output is 0 0 0 and 1, means what, for 0 0 it is 0, for 1 0 it is 0, for 0 1 it is 0, for only 1 1 it is 1. So according to the truth table of the AND, so what will be the output of this 0 0? So we are performing the operation bit by bit, so we are not performing whole at a time. So first bit with this bit, so 0 0 output is 0. Now 0 1, again AND operation giving the output 0, 1 0, it is giving the 0. So what we are going to do, we are performing the bit by bit operation, right? We are performing the bit by bit operation, and 1 1. Okay, what is the meaning of, now what is the output of or result of 1 and 1? That is 1. So what will be the output? 1 0 0 0. Okay, so that is in a 8. So what is the, after performing the AND operation, the output or result will be 8, right? So that this operation we are going to perform using the 8086 programming. So now how the source operand, that may be an immediate, a register, or a memory location, to the destination operand, that may be a register or memory location. Now there are two operations, first source and destination. So their source operand is what? Suppose I am writing here first source operand, it can be a immediate. Immediate means what? You can directly give the value. Suppose I want to do the AND operation with 3BA. So that is a hexadecimal value 3BA. I want to perform the operation on a 3BA. So what? I will directly give the value that 3B. Okay, that is nothing but called as a immediate. Okay, now a register. Suppose I am going to store the value in the register. So I will take the register as a memory location. Again we are going for the memory location. Okay, so directly can access the data from the memory location. Okay, so immediate, register, and memory location. So these three positions, or we can say the three locations that we can access the data. Okay, that is nothing but your source. Now what is the destination? Okay, so destination means where we are going to uh, save that data at destination mode. So that is nothing but a register or memory location. That cannot be an immediate value. Okay, so it is nothing but what? Register or memory location. The result is stored in the destination operand. Now after performing the operation, after performing the AND operation, where will be the result stored? So that is very a common question. Now where the result, where I will see that result, or where I am going to look for the result, that result is stored into the destination operand. Okay, after performing the operation, I will show you by using the example. Now at least one of the, here at least, sorry, where we are, okay, at least one of the operand should be a register or a memory operand. Okay, so from the source operand or destination operand, from both of them at least one operand should be a register or memory operand. Okay, both the operands cannot be a memory location or immediate operands. Okay, so we are not using both the location as a memory location. Suppose I am taking the both values from the memory location, that is not allowed. So at least one location should be a register. Okay, so you cannot take both the locations as a memory location or immediate operands. Okay, so the example of this instruction are as follow. Suppose I am performing the AND operation. Okay, suppose I am performing here the AND operation. So memory or register. So what here? So your source operand will be a memory or register. It can be a anything. Again, your destination operand is also memory or register. Okay, in register 2. So it can be, but you cannot take both the memory locations. You cannot take this memory or this memory. Okay, so you cannot take both the operands as a memory location. They must be a different. So that is the meaning of this sentence. Okay, now memory register or memory register 1 and memory register 2. So we will take one example here, and BL and CH. Okay, and BL and CH. Okay, so these are nothing but what? BL is one of the register, CH is the memory location. So what we are going to do? So sorry, CH is the immediate data. Okay, CH is what? Immediate data. So what we are going to do? So here, and memory or data. So there is a one, we will take one example here. So data is directly moving to the memory location. Whatever the data, we are going to move into the memory location. Suppose the source is this and destination is memory location. So what, the where the result will be stored? The result will be stored into the memory. Okay, the result will store into the memory. Similarly here, first memory or register 1, memory and register 2. So whatever the output or result will be stored in memory or register 1. So that is the example is what, and start comma 0.05h or hexa, we can say 05 hexa. Okay, so here C is the data here, so that is nothing but the example is what, I am taking what, start is the destination operand and 05 is the immediate data. So start is nothing but your memory location and 05 your value, or we can say the data. So from that location and these are location we are performing the AND operation, and the output is going to store in again into the memory location. Okay, so I will take the another example. So register and the data. Okay, now here what, operation memory and data. Here we will take the data, register and data. So your data, or you can see immediate data, that we are going to and we will do the AND operation with the register. Okay, and the output also going to store into the register, that is in the destination operand. Okay, that we already explained in the above slide. So that example what it says, so register and data, we are performing the AND operation between them, and where will the register result store into the register. So here is the example, and AL means what, that is nothing but one general purpose register. Okay, and FOH, okay, sorry, F0H, so that is nothing but your hexadecimal immediate value. Okay, so we are performing the operation, the data in AL and FOH, F0H, and what we will do, we will store the result into the AL. Okay, similarly, and a data, we will take another example here, and a data. Okay, so A is nothing but the AL or AX, that is nothing but your what, general purpose register. Okay, that is another example. So the data, that is nothing but the source destination, sorry, source operand. A is the destination operand. We are performing the AND operation between A and the data, and the result we are going to store into the A. That A is nothing but your AL or AX. Okay, that is nothing but your general purpose register. If you want to see the result, you can directly see your AL. Okay, now this is nothing but the example, and AX comma 1021H. Okay, so 1021 is the data, and the AX is the register value, or the value into the register. So we are performing the AND operation between AX and 1021 hexa, and that result is going to store into the AX. Okay, so I hope you understand the different addressing modes and how the data can be accessed from the different location and perform the AND operation. Okay, so that is what the logical operation using the AND. Now OR, in the logical OR, the OR instruction carry out the OR operation in the same way as described in a case of the AND operation. The limitation on a source and the destination operands are also the same as the case of AND operation. Okay, so I will not repeat due to the time limit. So whatever the I have explained in the AND, similar things will be happen into the OR operation. Means what, there is a bit by bit operation. Okay, so every bit can be perform a bit by bit operation. Then a source operand, that may be an immediate register or memory location. Okay, then destination operand, that may be a register or memory location. The result stored into the destination operand. Okay, and at least one operand should be a memory or register, and both the operands should not be a memory location or a immediate values. Okay, so these are all the rules whatever we have discussed in the AND operation. Same rule apply for the OR operation. Now we will see the programming here. So first we'll go for OR. So this is nothing but the memory register and memory register 2. So you can save the data in the memory or register, as well as destination is also memory or register. So here memory register, here is nothing but one your that is a destination operand, and this memory or register, that is a source operand. So whatever the operation, so whatever the value in the destination as well as in the source, both are perform the OR operation, and the result is going to store in the memory register, that is nothing but in the destination operand. Okay, where is the destination operand, where you can store your result. So how the OR operation should be performed? Suppose I will take again 12 and 10. So it is nothing but what? 1 1 0 0 1 0 1 0, right? So when we perform the OR operation, so you must know the truth table of OR. So what is the truth table of OR? Any value of the 2 is 1, then output will be 1. If both are 0, output will be 0. So what is the result? So result is what? 0 1 1 1. So what 0 0 0 1 1 0 1 1, right? So this is what the operation. So in that, what happened when both the zeros, okay, here is 0, here is 0, output is 0. When 0 1, output will be 1. When 1 0, output will be 1. When both the ones, it output will be 1. Okay, so likewise we are performing the OR operation. So we can see here the programming or BL comma CH. Okay, here is one, take an example, or BL comma CH. CH is nothing but what? One data. C is the data, so that is nothing but decimal. How much? 11 12 and 13. 13 means C. So that data we are going to do the OR and OR operation with the value which is stored into the BL. Okay, so BL is nothing but your register. Okay, and where the result will be stored, that result is going to store into the BL. Similarly, or memory data. So or memory data means what? Whatever the memory is the destination operand and data is the source operand. So whatever the direct immediate data, so data can be a ch or anything, 10 12 b a ah bh. Okay, so that is in the hexa. So that memory location having the one data, so we are accessing the data at the memory location as well as from the immediate data, and we are doing the OR operation in between them, and the result will be stored into the memory location, that is your destination operand. Okay, so here that have shown memory, okay, memory and data performing the OR operation, and the result is stored into the memory, right? So here is one taken an example. So the start is the memory location and 05 is the data. So we are performing the operation or operation, the result will be stored into the start. Okay, so here is or start comma 05h, that is another example we have taken. So start we can take as a register. Now in the previous, that is a memory location. So here the start we can use as a memory location, sorry, register. Okay, register location. So we are performing the operation of or with the register and the data, and the output will be stored into the register. And so that is one example here. Or AL comma FOH. So AL is the register and FOH is nothing, F0H is nothing but the F0H is the data. So that data and the register, we are performing the OR operation, and the result will be stored into the register. Okay, similarly here, or a comma data. So a is nothing but another register, and we are performing the a is nothing but al or ax. Okay, and we are performing the a or operation with the a and data, and the result will be stored in a. So here we are taking example. So your real time value is 1021 hexa, and the register value al. Okay, the register value can be anything that we can directly store. Okay, first we will use, you can use the one instruction, move al comma 200 or 2bh, anything. Okay, so that 2bh will be moved into the a operation in a data, or sorry, in the memory location or register. Okay, so likewise that is nothing but your or operation. Now we will go to the NOT operation. In the NOT operation is very simple. So in the logical inverter, or it can say the logical invert. So means what? When this is 1, when this is 1, output will be 0, and when it is 0, output will be 1. So that's what very simple operation, that is a NOT. So the NOT instruction complements or inverts the contents of an operand register or a memory location bit by bit. So NOT register, suppose that is a value 12. Okay, suppose here is a 12 value. Okay, so 1100. So how it is a 12, I will write in a digital format. So 12 bar means what? I want to make it a invert, okay, or a complement. So 0 will become 1, this 0 will become 1, this 1 will become 0, this 1 will become 0. So just invert. Okay, so here not register means what, whatever the value in the register which get converted into the complements or a invert. So and the result will the store in the same again in the register. So you can simply write not ax, suppose you can simply write not ax. Okay, so the not ax, what it can does, so it simply negate the ax operation. Okay, in you can do it with the again with the memory also. Okay, so whatever in the memory we can paste that data and you can negate that, or you can make it invert and store into the memory location. So here not si, that is one example. Now XOR. So in the XOR logical execution, or the XOR operation is again carried out the similar way to the and OR operation. The constant has on a high output when the two inputs bits are dissimilar, otherwise the output is 0. So what is the truth table? The constant on high output when the two inputs are bits are dissimilar means what? So here 0, I will write here. So 0 0 0 1 1 0 1 1. Okay, so 0 0 means here is 0 0, here is 1, here is 1, and here is 0. So both dissimilar operations will be 1. Okay, so here again same all the rules we have discussed in the OR and X and both are same. Okay, so it can be a memory or register, you can use both. Okay, we can performing the XOR operation and the result will be stored into the destination operand. So here is the example XOR BL and CH. Okay, similarly memory and data. Okay, XOR start 05H. Okay, so the immediate value and do the XOR operation with the start. Okay, and after performing the operation the result will be stored into that memory location, that is the start. Similarly, if you are use the register, so data and register, so performing the OR operation and result will be stored into the register. Okay, and here is the example XOR AL comma F0H, and the result will be stored in the EL after XOR operation. If you take the register here A, there is another example. So we are performing the OR operation, XOR operation with A XOR data, and the result will be stored in a AL and XOR. So these are the very basic logical operation that I already explained in the slides. If you have any doubts or any problem, you can ask me. Now you can write the program. Exactly, I am just shown the how exactly the data or instructions can be written. Now you can go for exactly programming how the programs can be written. First you can move one value into the register, then take the immediate data and do the OR operation. You can see the results. Okay, after in the emulator. Okay, while doing the programming you can go for the this operation. So this is done for today's lecture. Okay, we will come with the new programming in the next lecture. So thank you very much.